What crushed the ARA San Juan? Out in the middle of the ocean, far below where sunlight can even reach, massive machines move silently through the darkness. Submarines. But here's the real question. How do these steel giants float, sink, and dive into crushing depths without being destroyed? It all starts with a simple rule of physics, Archimedes Principle. It says that any object placed in water experiences an upward force equal to the weight of the water it pushes aside. If that upward force is stronger than the object's weight, it floats. If it's weaker, it sinks. Submarines use this principle to control their density. Inside the submarine are special tanks called ballast tanks. When the crew wants to dive, they open valves and let seawater fill those tanks. The submarine becomes heavier, its overall density increases, and it begins to sink. To rise back up, compressed air is pumped into the tanks. The air forces the water out, making the submarine lighter. Its density drops, and it heads back toward the surface. But ballast tanks aren't the only control system. Submarines also have diving planes, underwater control surfaces that work like airplane wings. As the submarine moves forward, adjusting these fins directs it upward or downward. And that forward motion? It comes from powerful propellers at the rear. Now here's the scary part. The deeper a submarine goes, the more extreme the water pressure becomes. At just a few hundred meters below the surface, the pressure is strong enough to crush weak metal like a soda can. That's why submarine hulls are built from incredibly strong steel alloys. And every submarine has a maximum operating depth. Go beyond it, and the risk becomes catastrophic. A tragic example is the Argentine submarine ARA San Juan. In 2017, it disappeared with 44 crew members on board. Its last communication mentioned a battery-related issue that had reportedly been contained. Shortly after, an unusual acoustic signal consistent with an explosion was detected underwater. It took nearly a year to locate the wreck, resting at a depth of 907 meters. At that depth, the pressure is overwhelming. Recovery operations would be extraordinarily complex, dangerous, and incredibly expensive. And so, the submarine remains there, silent in the darkness of the ocean. If you're fascinated by the hidden mechanics of our world, consider supporting the channel so we can keep exploring more mysteries together.